Okay, good afternoon, everyone. Welcome to the first ever MTV Virtual Student Research Symposium. I'm happy to see so many of you connected already. My name is Sean Clark. I'm a research faculty at the University of Michigan and the Associate Director for this consortium. I'll be serving as the session chair for this first session today up until the first break. So before we get started proper, I would like to go through a little bit of overview about the event today, just kind of the format, what you can expect, and a little bit of logistics. So with that, I'm going to get started. So we're excited to say we have more than 200 people signed up for this research symposium, which is really exciting for us to showcase our students and the incredible research that we're doing so far under the MTV. You can see we have 36 research presentations laid out for you, and then below that you can see a breakdown of the various participation that we have registered for this symposium over the next 3 days. So we have a very large national lab contingent, which we're very happy to see. 86 of our national lab colleagues registered for this workshop, and we're really excited to engage with you and get your feedback and just build some collaborations over the next 3 days of presentations. Also, 44 from academia, 30 from across the US government, whether it's DOE, some DOD folks I know registered, and Homeland Security. So we're excited to see all the interagency interest in this work as well. And we have a few folks from industry, which we're always happy to collaborate with you. In terms of the format, so this is a 3-day event, so it's approximately from 1 until 5:20 over the next 3 days. You're going to see roughly 12 talks per day. These are going to be 15-minute-ish talks from each of our student presenters, and the students have been instructed to have a 12-minute presentation actually and leave about 5 minutes for questions. So we will have time for question answer discussion period after each of the talks. So we're happy and excited to have you all engage with us in that way. There will be a break halfway between on each of those days where we'll switch session chairs, and again we'll be going until 5:20. At the end of the first day, which is today, Tuesday, from 6 p.m. we're going to have a virtual happy hour. So this is something we're trying in this virtual format to allow a space for us to connect in a less formal situation, to get in a Zoom room and try to in some way mimic those informal interactions that we have at in-person meetings. So we're going to give this a go tonight from 6 to 7 p.m. So we encourage you to grab a beverage, join us from 6 to 7, and we'll be having a conversation about research in the COVID-19 era, just to hear some strategies, some things that have worked, things that haven't worked, and just kind of share our experience in this new and challenging time. So we hope all of you can join us for that. It's going to be occurring on this same Zoom line that we're in now. At the close of the workshop, we're going to have another set of happy hours, again, to try and mimic that social interaction. And we're going to have 3 separate rooms, each one dedicated to one of the MTV thrust areas. So these will be led by faculty from those thrust areas, and it'll give a chance for students and lab scientists and faculty to come together and just debrief a little bit, talk about the research, build some collaborations, and again, have that informal interaction. And again, that'll be Thursday evening from 6 to 7 p.m. Eastern. In terms of the meeting logistics, so if you're here, you know this meeting is happening on Zoom. The full agenda you can find on the website, which was distributed by email. It's also in the calendar invite. The link is also here on the screen. On the website, you'll find the Zoom link to all the sessions. There's a join button next to any talk. Those join buttons all take you to the same Zoom room. The entire meeting is going to happen in this same Zoom room. So anytime you want to join, if you have to step off and come back, you can find us in this exact same spot. You'll also find links to all the talks there in PDF format. So if you're connecting on a phone, or if you want to look at the talks afterward, you can find all the PDFs there. The titles are linked to those files. As you probably noticed, this meeting is being recorded. So we will be making these recordings available at a later date through our website, so you can view them if there's a talk you missed or there's something you want to go back to. Lastly, we asked that you would just keep your microphones muted unless you're speaking. Please utilize the chat function. If you have a question during the talk of one of the speakers, you can drop that in the chat. The session chair will moderate those questions if you want to put them in the chat. You'll also be able to unmute and ask your question live after the talk if you prefer to do it that way. But again, just please keep your microphones muted unless you are speaking. And with that, that's the end of my short introduction. So I'll ask if you have any questions or comments or troubles, just please drop them in the chat. If you have any trouble connecting or anything, just put it in the chat and we can address those questions as they come up. But I'd like to move along to our first speaker, which is the director of the MTV, Professor Sarah Pozzi, who's going to give us an overview of the MTV research activities and some research highlights that we've had over the first, almost a year now. So Sarah, please.
Great, thank you, Sean. It's really fantastic to see everyone here. I'm very excited about this Student Virtual Research Symposium occurring over the next 3 days. As Sean mentioned, we had a fantastic turnout. 200 folks approximately signed up for this symposium, and we'll be following our students, all their presentations, and asking questions and comments. And we really want to highlight that possibility of interacting with our students and our teams, and look forward to it over the next 3 days. So our consortium is motivated by the non-proliferation mission, which is to say we are interested in preventing the further spread of nuclear weapons around the world. So this is a really important societal problem that we have right now around the world. It's paramount to our national security. And so it's a mission where our students are engaged and interested in helping with our research project in this much broader topic. So within our consortium, we are interested in detecting nuclear proliferation activities. And what we mean by that is detecting if a country is going down that road where they are developing the possibility of developing a nuclear weapon. And that is, of course, in contrast to the peaceful applications of nuclear technology. That is, for example, using nuclear power to generate safe and clean electricity for a country's population. And so a lot of our work is looking at detecting nuclear proliferation activities, and if there were to be a nuclear explosion, certainly hope that we don't get to that point, but if we were to get to that point, then how do we detect that explosion? How do we characterize it, determine that it is in fact a nuclear explosion, and be able to characterize and detect explosions around the world? So it's both pre-detonation and post-detonation forensics. So our team here is consisting of 14 universities. You can see these universities on this map, widely distributed throughout the country, and working closely with 13 national laboratories. You can also see the national labs highlighted here on this map. So we have a broad distribution. Each of these participants here brings a very specific knowledge and technology development that is helpful for our overall strategy and mission. So in this graph here, you can see how we subdivide our activities into 3 thrust areas. These are technical thrust areas where our projects are located. We have the fundamentals of nuclear particle physics, looking at fundamental studies in reaction theory, modeling, in imaging, and in anti-neutrino-based methods. A lot of the talks we'll hear today are along this first pillar. And then we have another pillar, which is in the signals and source terms of nuclear nonproliferation. So how do we detect that activity that I was talking about before, where somebody is trying to develop a enrichment capability, for example, or something like that. So what are the techniques that we can use? And so throughout this thrust, we are working on those types of projects. And finally, the third thrust is in explosion monitoring. And so that is where we want to be able to detect an explosion, to determine that it's a nuclear explosion, and to be able to say something about it, like characterize its yield. So here we have experts in infrasound, seismology, transport of radionuclides, radionuclide detection, and environmental sampling, as well as background monitoring. So all of these topics will be covered within our next 3 days by the students who are working on these individual projects. We also have 3 cross-cutting areas, and these include modeling simulation, policy, and education and outreach. And these activities go across all 3 of these technical thrusts. So this consortium is a 5-year effort, and we are in the first year of that effort. So we are in the startup phase, as you can see in this graph here, and we've held our kickoff workshop. We've recruited students and postdocs to work on our projects. We've awarded fellowships and introduced these young scholars into the research activities and in the collaborations with the national laboratories. We've also began the phase 2, which is a development phase, which is actually developing these nuclear non-proliferation technologies in the 3 thrust areas. So we've established these cross collaborations among universities and national labs, and we've implemented fellowships, not so much on the travel side, because as you know, a lot of the travel right now has been canceled, but we hope to return to that very soon. So as an outcome from the consortium, you can see in the arrow pointing down, we're planning to have over 100 PhD and master level students come out of this effort, over 100 undergrad students, outreach events going down to elementary, middle, high school students, and of course our new technologies in non-proliferation and security. So I want to highlight a few of our students across the different thrusts here. In the first thrust, fundamental physics, we have Tyler Johnson. Tyler is working at Duke University on a fascinating project looking at the possibility of fission happening as a result of neutrino interaction with nucleus. So this is similar to regular neutron-induced fission. Well, this time the fission is induced by a neutrino. And of course, the cross-section is a lot smaller. And so we're working on this project in collaboration with Duke, and it's really fascinating to see this fundamental physics project. Also, looking at neutrino detection, Connor Awe is working to use neutrino detection to determine the possibility of finding a nuclear reactor that is being hidden. And as we know, nuclear reactors can be used to produce plutonium. And plutonium is a special nuclear material that in turn can be used to fabricate a nuclear weapon. And so here we are looking at neutrino detection for the discovery and localization of nuclear reactors. In TA2, we have Kelly Traw at University of Hawaii, and she is working on the use of laser-induced fluorescence to observe biological samples. And here you see an example of her work where she's analyzing moss samples, and some of that moss was treated with a metal, in this case it was copper, and then exposed to the UV light. And so with light, basically you can see how the treated sample is showing that treatment, whereas the untreated sample is not showing it. So clearly what we want to do here is then extend this method to measuring things like uranium and plutonium that we're interested in non-proliferation. Another student, Lauren Finney, here at the University of Michigan, is looking at laser-based spectroscopy for detection of uranium. And we're doing this in a remote setting. So we're shining that laser, and the idea is that the laser can travel for several meters, up to tens of meters, and hit a sample, and then we detect the emissions from that sample and determine that we have here a uranium. And so in this project, we've had success in the past where we were able to determine a highly enriched uranium versus depleted uranium for these samples. Nathan Diha is also at the University of Michigan, is working on techniques to detect nuclear explosions, nuclear explosion monitoring. So what we're doing here is using a new material, just an organic glass developed by our collaborators at Sandia National Laboratory, and actually casting these materials into different shapes and forms in our research group at the university. And the idea is to develop a new detector for radioxenon detection. As you know, radioxenon is a double gas that can be used as a signature for a nuclear explosion. One of the main ideas for this consortium is to train the next generation of scientists and engineers. And here you see an example of one of the activities where that training is happening in collaboration with our national lab partners. This is the nuclear safeguards class taught at the University of Michigan, and the trip that we took last fall at Oak Ridge National Lab. So you can see how these students are able to interact with professionals at the national labs and to be able to learn about safeguard science and nuclear nonproliferation from experts in the field. So this is a very exciting activity. Education and outreach, we have 132 students currently involved in our MTV research. You can see the subdivision there into undergraduate students and graduate students, and then the fellows and the associates. So the fellows are fully funded by our consortium. The associates are partly funded, are funded by other sources, but are still contributing to our research activities. So in addition to our students, we're actually going to much younger students at elementary, junior high and high school level, and bringing them into our laboratories to learn about nuclear science and engineering and learn about the exciting careers that can be had in this field. And so this is an important activity that is happening within our consortium. This summer, because we were really limited in terms of travel, we have transitioned our outreach into a fully virtual model. And we're teaching a nuclear engineering summer school, the 12-week program. It's really a student-led activity. We have a few invited speakers, including many who are on the line now. And here we have virtual classes that occur for 1 hour every day, most days. And you see an example of one of these classes here on the right, where Jorgen Randrup, one of our national lab partners, is teaching a class on the fundamentals of nuclear fission. And we have about 200 students registered from the US and around the world. This graph here shows the MTV Student Advancement model, where we are taking a student from undergraduate program, getting them into graduate program, and supporting their graduate career throughout their studies and leading up to their graduation. In this case, we have Connor, and we're seeing that he's a fifth-year student, so he's going to be presenting later this afternoon, and I'm sure he's looking for a job. So if anybody's interested in hiring some of our students, and I know many labs and universities are. So here's an example of one of my former students, Cameron Miller. Cameron has defended his PhD just last year and is currently a technical program analyst at the Department of Homeland Security CWMD office. So this is an example of a transition into a government agency for one of our students. Earlier this year, in January, we were glad to host Ms. Lisa Gordon-Hagerty, the Undersecretary for Nuclear Security and NNSA Administrator. You can see her in the photo at the left, listening intently to one of our students, presenting on their research. So we're really excited to have her here at the University of Michigan. So I'm going to close this brief presentation with some of the highlights of our first year accomplishments. We've worked on 3 thrust areas within the MTV. In the first thrust area, we've measured and quantified neutron gamma ray correlations from the spontaneous fission of californium. We've demonstrated an antineutrino detector. In TA2, we've looked at reactors and looking at burnup and predictions for nuclear reactors. We've demonstrated laser-based characterization of MOS samples. In TA3, we've detected infrasound from the Falcon 9 rapid scheduled disassembly using sensors that are placed in smartphones. And we've developed organic glass fabrication facility to be able to cast cells for radioxenon detection. So finally, I want to thank our sponsors. None of this could be possible without the support of the NNSA and the Department of Energy, who's sponsoring our consortium. So with that, I will end the presentation and ask if there are any questions.